So commutative property. So that is A dot B is equals to B dot A. So next, if n is scalar, n greater than 0, m into a bar dot b bar is equals to m into m into a bar dot b bar. So scalar multiple of dot product also equal m into a bar dot b bar is equals to m into a dot b. Next, m comma n are scalars. So we can say m into a bar dot n into b bar is equals to m into n into b dot a. So this condition also satisfies. Got condition for orthogonalities. Let A comma B are two non-zero vectors perpendicular to each other. So if the two vectors are perpendicular to each other, then the angle must be equals to pi by 2. The angle between two vectors should be 90 degrees. So that is pi by 2. Then we can say that the two vectors are orthogonal to each other. So conversely, if A comma B are two non-zero vectors, A dot B is equal to 0. So mod A into mod B is equals to 0, cot theta is equal to 0. So when cot theta is 0, if theta is equals to pi by 2, then cot theta should be 0. So therefore theta is equals to pi by 2. So thus A comma B are orthogonal to each other. So that is A comma B are perpendicular vectors. So let us, we know that I comma j comma k are unit vectors along the mutually perpendicular axis. From the above discussion, so we have a dot I dot j is equals to j dot k is equals to k dot I is equals to 0. So these are the perpendicular to each other in coordinate axis, x axis, y axis, z axis. So I along x axis, j along y axis, k along z axis. So therefore, x, y, z are perpendicular to each other. So similarly, I, j, k also perpendicular to each other. So therefore, I dot k, I dot j is equals to j dot k is equals to k dot I is equals to 0 because I, j, k are perpendicular to each other. Also, by the definition of dot product, I dot j is equals to mod I, mod I cos theta. So 1 into 1 into 1 is equals to 1. So I dot I must be is equals to 1. Next, similarly, j dot j is equals to j dot k is equals to must be 1. So therefore, I dot I is equals to j dot j is equals to k dot k is equals to 1. So but I dot j is equals to j dot k is equals to k dot I. All are always zeros. So next, let R is equals to xi plus yj plus zk with any vector. So then R dot j bar is equals to xi I bar plus yj I bar plus zk I bar. So these all are should be zeros. So x into I dot I must be 1 plus remaining y into 0 plus z into 0. So therefore x. R dot I is always X. R dot J is always Y. R dot K is always Z. Similarly, so therefore R dot I is always X. Next, R dot J is always Y. So next, R dot K. R dot K is always Z. No. If A comma B are parallel vectors, then A dot B is equals to, so if two vectors are parallel to each other, then the angle between two vectors should be 0. So mod A into mod B cos 0. So that is equals to mod A into mod B. If A comma B have same direction, next A dot B is equals to mod A into mod B. So cos phi. That is nothing but it has opposite direction. So that is mod minus mod k into mod b. So it indicates two vectors are opposite direction. If the same direction is nothing but it should be positive. But theta should be equals to 0. Opposite direction means that theta should be theta should be pi. It gives negative of minus mod A into mod B, length of a vector. If A is non-zero vector, A dot A is equals to mod A into mod A cos theta cos 0. That is equals to mod A square. So length is nothing but mod A is equals to root over A dot A. So this is the length of a vector. Geometrical interpretation of scalar vector. So let A bar and B bar are two vectors represented by OA and OB bar respectively. So draw BM perpendicular to OA and AM is perpendicular to OB as shown in the figure. So let theta be the angle between OA and OB. So this is the theta. So this is the angle between OA and OB. Next, some triangle OMB. The triangle OMB. So we can say that cos theta. So we can write cos theta value opposite different side of the theta by hypotenuse. So OM by OB. OM by mod OB. So that is OM by mod B. Indicates B vector indicates the distance between O to B. And A vector should be indicates O to A. So OM is equals to mod A into cos theta. So projection B on A bar is equals to projection OB bar on OA bar. So that is equals to OM is equals to mod B bar cos theta. So mod A mod B cos theta by mod A. So that is equals to A bar A dot B. So A dot B dot direct definition mod A into mod B into cos theta. So that is A dot B. A dot B by mod A equation. Now, similarly, we can get A dot B by mod B bar. So similarly, triangle A and A. So in this triangle, so we can take same cos theta is equals to ON by OA. So ON by mod OA. ON by mod A. So ON is equals to mod A into cos theta. So projection A on B. So that is equals to projection OA on OB. That is equals to OM is equals to mod A into cos theta. Mod A into cos theta. So mod A into mod B cos theta by mod B. So similarly, A dot B dot product definition A dot B is equals to mod B cos theta. So numerator A dot B by mod B equation 2. From equation 1 and 2, so we can say that A dot B is equals to mod B projection of B on A bar. So magnitude of A bar projection of B bar on A bar. From equation 2, A dot B is equals to B bar projection of A bar on B bar. So that is equals to magnitude of B bar and the projection of A bar on B bar. So thus geometrical interpreted the scalar product of two vector in the product of the magnitude of one vector and the projection of other vectors in its direction. Next, distributive laws. So distributive property and scalar thread. The scalar thread of vectors in distributive over addition of vectors for any three vectors A comma B comma C, A dot of B plus C is equals to A dot B plus A dot C. The second one, B plus C into dot A is equals to A dot B dot A plus C dot A. So proof, let A bar comma B bar comma C bar are three vectors represented by OA, OB, and OC respectively. So So we can see diagram. So we can draw BM is perpendicular to OA. So BM is perpendicular to OA and OM and when OM are positions of B comma C comma and E plus C respectively on A bar. So these are the BM, C and R projections on A bar. So that is vector A bar. So that is OA. A dot B is equals to mod A into OM dot A dot C. So that is equals to mod A into MN. And A dot of B plus C is equals to mod A into OM. That is equals to mod A bar OM plus MN. So that is equals to mod A bar dot OM plus A bar dot MN. So A bar dot B bar is plus A bar the C. Hence, hence proof. So here B plus C dot A bar is equals to A dot B plus C. So commutative. So we can say that. So these are the distributive laws. A dot of B plus C is equals to A dot B plus A dot C. Second condition, B plus C bar is dot A bar is equals to B dot A plus C dot A. So these are the distributive laws in vectors. Dot angle between two vectors. This is an important one. Angle between vectors. If theta is the angle between vectors A and B, so then we can write A dot B is equals to mod A into mod B by cos theta. So here we can write cos theta is equals to A dot B by mod A into mod B, or theta is equals to cos inverse of A dot B by mod A into mod B. So this is the formula for angle. We have to find out angle between two vectors. If angle between two vectors are perpendicular to each other, then we can say that A dot B is always zero. Here, A dot B is always zero if the two vectors are perpendicular to each other. So, example, find the dot product of vectors. A is equals to I plus 2j plus k. And B bar is equals to 2a plus 4j plus 5k. The solution A dot B is equals to I plus 2j plus k dot 2i plus 4j plus 5k. So 2 into I dot I must be 1 plus 2 into j dot j must be 1 plus 1 into 5 into k dot k must be 1. So that is equals to 15. So this is the dot product of A and B is answer 15. So next is asking for what values of x the vectors A bar 2a plus hj plus k and b bar is equals to 2j minus 2i minus j are perpendicular to each other. So we know that the two vectors are perpendicular to each other, then the dot product must be zero. So we can apply this. A dot B are perpendicular to each other. A comma B are perpendicular to each other. We can write A dot B is equals to zero. So this is A vector. 2i plus j plus k dot 2i minus j. Here there is no k. So we can take 0 into k bar, always 0. So that is equals to 0. Dot product must be 0. Condition of perpendicular of two vectors. Dot product A dot B is always 0. Therefore, dot product 2 into 2 plus x into minus 1, 1 into 0 is equal to 0. So 4 minus x is equals to 0, x is equals to 0. So therefore, if x is equals to 0, then then the two vectors are perpendicular to each other. So next example, find the angle between them. A bar 2i plus 2j minus k and b bar 6i minus 3j plus 3k. The solution. Our assumption theta be the angle between two vectors, then cos theta formula. Cos theta is equals to A dot B by mod A into mod B. So mod A is nothing but magnitude. Mod A comma mod B. So mod A into mod B. So these are the magnitude of two vectors. A dot B 2i plus 2j minus k into dot 6i minus 3j plus 2k divided by magnitude of A 2 square plus 2 square minus 1 square. First vector, second vector, root over 6 square plus 3 square. Next, k coefficient, 2 square. So this is the magnitude. So 2 into 6, 12, minus 6, minus 2, divided by denominator, root 4 plus 4 plus 1. That is 9. Root 9, 36 plus 9 plus 4. So 4 by 3 into 7. So 4 by 21. So therefore, cos theta is equals to 4 by 20. Cos theta is equals to 4 by 21. Theta is equals to cos inverse of 4 by 21. So this is the angle between given two vectors. So next, if A comma B comma C are three vectors such that A plus B plus C is equal to 0, and also if then mod A is equals to 3, magnitude of A is 3 and Magnitude of B also B is 5. Magnitude of C is 7. Then find the angle between A and B. He is asking find the angle between A and C. So given that A plus B plus C is equals 0 now, so we can write A plus B is equals to minus C. So squaring on both sides. A plus B whole square is equals to minus C square. A square plus 2AB plus A square is equals to C square. So that is mod C square. A square value. So we know that mod A. So mod A is 3 square plus 2 into mod A into mod B. So that is 2 into 3 into cos theta plus B square mod B. So mod B 5 square is equals to C square is 7 square 49. You simplify. So cos theta is equals to 15 by 30. So cos theta is equals to 1 by 2. So therefore, so in cos theta, theta is 30, theta is equals to 60. Then cos theta value 1 by 2. A and B is 60 degrees. Example, find the projection of two vectors. A bar is equals to 5 minus 2j plus k on the vector B bar is equals to 4i minus 4j plus 7k. Projection of A and B bar is A dot B by B bar. Next projection of B and A bar is formula A dot B by A bar. A dot B I minus 2j plus A dot 4i minus 4j plus 7k by the root over 4 square plus minus 4 square plus 7 square. That is magnitude of B. So 19 by 9. So this is projection of A and B. The next, find the unit vector perpendicular to the plane A 2i minus 6j minus 3k and b 4i plus 3j minus k. So let xi plus x2j plus x3k be a perpendicular vector to the plane a bar and b bar. A dot b is equal to 0 and b dot a is equal to 0. So a dot b and b dot a is equal to 0. So a dot b 2xi 2x1 minus 6x2 minus 3x3 is equal to 0. So this is a dot x and b dot x 4x plus 3x2 minus 3 is equal to 0. Solving these two equations, we are getting x by 3. X by 3 is equals to x1 by 3 is equals to x2 by minus 2 is equals to x3 by 6. So therefore, x bar. So vector x bar 3i minus 2j plus 6k. So this is the x bar vector. నమస్తే రావు అంకుల్ ఏం సంగతి రావు అంకుల్ సార్ ముందరుందని చెప్పిన నేను కాశ్మీర్ అదే చూస్తే అర్థం అవుతున్నది ముందరికి వెళ్ళని చెప్పినా నేను ముందరికి వెళ్ళంటే ఇక 5 నిమిషాలు లేదు ఏం చేద్దాం అంకుల్ క్లాస్ చెప్తున్నాడు ఆన్లైన్ లో ఒకటి మెసేజ్ లేడు క్లాస్ చెప్తున్నాను ఎగ్జిబిట్ అంతే అంకుల్ ఏం చేద్దాం ఇక ఎడవేరా అంకుల్ రా అంకుల్ అరే రా అంకుల్ జర ఒక అర్ధ గంట ఆన్లైన్ లో క్లాస్ చెప్తే పోతుంది 1 అవర్ అయితే అయిపోతుంది ఈ ఒకటి ఆన్లైన్ ఒకటే ఉంది అయితే అయిపోతుంది నెట్ ఉంది కదా The next unit vector perpendicular to the plane A and B is xy mod xi. So, so 3i minus 2j plus 6k by root over 9 plus 4 plus 36. That is magnitude of x bar. So therefore, 3 by 7i minus 2 by 7j plus 6 by 7k. So applications of dot product. So the dot product can be used to find the work done by a force. So this is the most important application of work done. So dot product. So dot product can be used to find the work done by force. So let OA, so this is the work done. Work done by force is denoted by F dot D. So force dot direction F dot D. So when a force is applied to O, so it is moving on O to A. So OA is equals to F be a force acting on a particle at a point O. Suppose the displacement of the particle O to B is given by OB is B bar. So after applying force, so the distance should be traveled by O to B. So that is O to N. O to N. So draw VM is perpendicular to OA. So this is after we can apply force to at a point O. So it will be traveled to O to B. So that is we can represent on OA axis. That is we can draw the BM to BM is perpendicular to OA. So by the displacement of the direction of the force, OM is equals to OB into cos theta. So mod A into cos theta. So therefore, work done by force. So W minus magnitude to the force direction of the motion into distance moved. So that is mod F into OM. So mod F into mod D into cos theta. So that is equals to F dot D, where F is force field and D is the direction. These distance. So therefore, work done by force, work done by dot product is F dot D. Example. By applying force, F is equals to 6j plus 8k. The particle changes its position from A 1 comma minus 1 comma 2 to B point minus 1 comma 1 comma 2. Find the work done by force. The distance covered from the moving particle A to B is AB is equals to OB minus OA. So that is OB vector minus I plus J plus 2K minus I minus J plus 2K. So we can see so that is minus 2I plus 2J. So therefore, work done F dot D. This force field is already given 6J plus 8K. So distance. So distance is covered by minus 2A plus 2J. So distance, we can find out the distance AB. AB is equals to OB minus AA. So this is the distance. So dot product 6 into 2. So that is equals to 12 units. The next thing, cross product of a vector. Cross product are vector product of a two vectors. The vector product of a cross product of a two vectors A and B is denoted by A cross B. So this is the A cross B definition mod A into mod B sin theta. So the theta is the angle between two vectors A and B. And here theta must be 0 to 180 degrees between 0 less than or is equals to theta less than or is equals to 5. The theta is the angle between A and B, and any way unit vector perpendicular to the plane A bar and B bar. A bar and B bar. The direction of one bar coincides with that in which a right-handed screw moves when it's rotated from A to B. So we can see here rotation of N from A to B. So clearly. So O to A is A bar vector, O to B is B bar vector, and the distance is moved by perpendicular vector in the plane. So that is N bar. and the angle between two vectors is theta. So clearly theta is the angle between two vectors. So note point, first one, by the definition of the cross product of any two vectors is zero, zero. Zero vector if the vector is zero, zero vector. The cross product is of a vector is perpendicular to the both A and B. The cross product of two vectors is proportional to length of each vector. So in dot product and cross product, this is the same condition. The cross product or dot product of two vectors is proportional to length of each vector. Next, the cross product of two vectors is not a commutative. A cross B is not is equals to B cross A. So this is the condition. But A cross B is equals to minus B cross A or B cross A is equals to minus A cross B. So cross product and dot product or cross product is always not satisfying commutative property. A cross B is equals to minus B cross A or B cross A is equals to minus A cross B. So this is the first property of cross product. Second one, if n greater than 0 is a scalar, then m cross A bar, m into A bar cross B is equals to m into A cross B. So this condition is satisfied. Next, n comma n are any two scalars. So this condition also satisfies. N into A bar cross n into B bar is equals to n into n into A cross B. Condition for parallelogram. Let A comma B are two non-zero vectors. If A comma B are collinear, then theta is equal to 0. Then they are perpendicular if the theta is equals to pi. So these are the two conditions. If the two vectors are collinear, then the theta is 0. If the two vectors are perpendicular, then the theta is pi. So sin theta is equal to sin 0, that is equal to r, sin pi is equals to 0. A cross B is equals to mod A into mod B theta dot n, that is equals to 0. So conversely, if A comma B are non-zero vectors and A cross B is equal to 0, then mod A into mod B sin theta dot n is equals to 0. So that implies sin theta is equal to 0, theta is equal to 0 or pi. So A comma B are either collinear or parallel. So in particular, A cross A is equals to 0. Also for unit vectors I comma j comma k. I cross I 0, j cross j 0, k cross k is 0. So we can see I dot I, j dot in dot product I dot I, k dot k, j dot j is always 1. But in cross product I cross I is equals to j cross j is equals to k cross k is equals to always 0. For unit vectors I comma j comma k, we have so I cross j is equals to k, and so reverse j cross I is equals to minus k. So similarly, k cross I cross k is equals to I, k cross j is equals to minus I, k cross I is equals to j, I cross k is equals to minus j. Next, distributive loss. The cross product is distributive over the addition of vectors, that is for any three vectors a comma b comma c, that is equals to a cross of b plus c is equals to a cross b plus a cross c. So this is only one condition distributive. A cross of b plus c is equals to a cross b plus a plus c. So cross product in terms of components. So let I is equals to a bar is equals to a1i plus a2j plus a3k, and b bar is equals to b1i plus b2j plus b3k. So a cross b is equals to a1i plus a2j plus a3k cross b1i plus b2j plus b3k. So we can multiply each and every term, or directly we can write in matrix form. So I, J, K. So first row is always I, J, K in cross product. Second row, first vector. Here we are taking A cross B or B cross A. In case we are taking B cross A, we are write B vector coefficients. So here A cross B, A1, A2, A3, comma. Next, third row B1, B2, B3. So expand this matrix, we are getting A cross B. For example, A bar is equals to minus 2I plus 2J minus AI, B bar is equals to 3I plus 6J plus 2K. Find A cross B. So A cross B is equals to I, J, K, first row. The next coefficients of A vector in second row. So that is minus 2, 2, minus 1. Next, the coefficients of B vector in third row. So 3, 6, 2. So find the matrix determinants. We are getting 10I plus J minus 18K. So this is the dot cross product. For example, A bar is equals to I minus J plus K. B bar is equals to I plus J K. Then find a vector whose magnitude is 5 and perpendicular to both vectors A and B. So we know that A cross B is a vector perpendicular to both vectors A and B. So that is A cross B. We have to find out A cross B. I, J, K, and first vector coefficients I minus 1, 1. So next, the second vector B coefficients 1, 1, 1. So simplify. So A cross B is equals to minus 2I plus 2K, 2J, 2K. Next, magnitude of this vector mod A cross B is equals to so root 2 square plus 2 square. So that is root 8. That is equals to 2 root 2. A unit vector perpendicular to A and B is A cross B by mod A cross B. So A cross B is minus 2I plus 2K divided by 2 root 3. That is equals to 1 by 2 root 1 by root 2 minus I plus K. So this is the perpendicular vector A to A and B. Its magnitude is 5 is so we can multiply 5 above vector. The vector is perpendicular to A and B and has magnitude 5 5 by root 2 minus I plus K. So the position vectors of a triangle are I plus J plus 2K, comma 2I plus 2J plus 3K and 3I minus J minus K. So find the area of the triangle. So we have to find out the area of the triangle. So ABC are the vertices of the triangle. OA first vector, OB second vector, OC third vector. So first we have to find out sides, AB side and BC and EA side. So AB is equals to position vector. So formula AB is equals to OB minus OA. So next AC is equals to OC minus OA. So OB 2I plus 2J plus 3K minus I minus J plus 2K. That is equals to I plus J plus K. AC is equals to OC minus OA. So 3I minus J minus K minus of I plus J plus 2K. So that is equals to 2A minus 2J minus 3K. So AC cross AB is equals to cross product of above two vectors. I J K. So 2 minus 2 minus 3. 1, 1, 1. So cross product. So we are getting vector I minus j minus 5j plus 4k. So we can take modulus. Or we have to find out magnitude of above vector. So mod AC cross AB is equals to root over 1 plus 25 plus 16. That is equals to root over 42. The area of the triangle is 1 by 2 mod AC cross AB. Cross product of any two sides of the triangle. So formula 1 by 2 cross product of any two sides of the triangle. So here we are taking AB and AC two sides. So therefore 1 by 2 AC cross modulus of AC cross AT. So that is equals to 1 by 2 root 42 square units. So this is the area of the triangle. So formula for area of the triangle by using cross product is So 1 by 2 modulus of any cross product of any two sides. So we can take any two sides cross product. Next, find the area of the parallelogram whose diagonals are A bar is equals to 2i plus 3j minus 6k and B bar is equals to 3i minus 4j minus k. Solution. So let ABCD be the parallelogram whose diagonals AC and BD is given diagonals in type two diagonals AC and BD. So these are the diagonals. So first we have to find out the area of the parallelogram. From the triangular law of addition, AB plus BC is equals to AC and AD plus BD is equals to AB. So adding these two, so 2AB is equals to AB plus AB bar. So that is equals to AC minus BC plus AD bar plus BD bar. So that is equals to AC plus BD. We can add these diagonals here with hard vertex. 2AB is equals to 5i minus j minus 7k. So similarly, 2AD is equals to AC minus BB. So AC minus BB. So after getting minus I plus 7j minus 5k. So AB is equals to 1 by 2 5i minus j minus 7k. AD is equals to 1 by 2 minus I plus 7j minus 5k. So therefore, vector area of the parallelogram. So that is equals to cross product of any two sides of a parallelogram. A cross AB cross AD. So 1 by 2 into 1 by 2 ijk 5 minus 1 minus 7 minus 1 7 5. So determinant of a matrix. So we are getting 1 by 2, 27i plus 16j plus 17k. So area of the parallelogram is, we are taking modulus of above vector. So 1 by 2 root over 27 square plus 16 square plus 17 square. So 1 by 2 root over 1 to 74. So this is the area of the parallelogram. So area of the parallelogram formula, cross product of any two sides. Magnitude of cross product of any two sides of the parallelogram, which gives the area of the parallelogram. So next example 1.13. A force given by F is equals to 3i plus 2j minus 4k is applied to the point 1 minus 1 2. Find the moment of F about the point 2 comma minus 1 comma 3. R is equals to OP 2i plus 2i minus j plus 3k minus I minus j plus 2k. So that is, this is the position vector R. I plus 0 into j plus k. So moment F is equals to R plus FR. So ijk 1 0 1 3 2 minus 4. After solving about determinant, we are getting minus 2ij 2i plus 7j plus 2k. So this is the moment of given vector. The next one, product of three vectors. Product of three vectors. Scalar triple product. So let A comma B comma C are three vectors. Then the triple vector A comma B comma C is denoted by box ABC. Is defined by box AB is equals to A dot of B cross C. So this is the symbol of product of three vectors. The box ABC is equals to A dot B cross C. So this product is known as box product, box product also. Properties of scalar of triple vectors. A bar is equals to A1i plus A2j plus A3k. B bar is equals to B1i plus B2j plus B3k. C bar is equals to C1i plus C2j C3k. In this box, first we have to find the cross product B cross C. So B cross C is equals to, so this is the B cross C value. So I into B2 C3 minus B3 C2 minus J into B1 C3 minus B3 C1 plus K into B1 C2 minus B2 C1. So this is the cross product. Next, multiply dot product. A1I plus A2J plus A3K. So after simplification, so we can write simply box ABC is equals to in first in matrix first row has first vector coefficients of first vector, in second row has coefficients of second vector, in third row has coefficients of third vector, that is modulus of a1 a2 a3 b1 b2 b3 and c1 c2 c3. So this is the box ABC. So we can similarly we can see that if first vector in box B, we can interchange the interchange the coefficients b1 b2 b3 C1, C2, C3, A1, A2, A3. So similarly, box C, A, C. C1, C, C1, C2, C3, A1, A2, A3, B1, B2, B3. So this is called triple product of a vectors A, comma B, comma C or box ABC. So we can observe clearly, we know that the above three determinants are equal. So box ABC is equals to box BCA is equals to box CAB. So position of vectors, position of values in determinant changed. The final result of the determinant does not change. It is always same. Next, the box ijk is always 1. Box jki is 1. Box kij is always 1. So therefore, box ijk is equals to 1. Box jki is equals to 1. Box kji also 1. By using equation 1, ijk is equals to minus 1 and kji box jik also minus 1. A is equals to A1I plus A2J plus A3K. B is equals to B1A plus B2J plus B3K. C is equals to C1I plus C2J plus C3K. Then A cross B. So previous case, A cross B dot C. A cross B dot C is nothing but we are getting minus. So negative of A1, A2, A3, B1, B2, B3, C1, C2, C3. But result is same, but opposite direction. So that A dot B cross C is equals to box ABC, that is equals to A cross B dot C. These three values are same. A dot B cross C is equals to box ABC, that is equals to A cross B dot C. So next note. So if A comma B comma C are coplanar vectors, then the volume of the trapezoidal is zero. So three vectors. Box A comma B comma C is equal to 0. Thus, a necessary and sufficient condition for A bar comma B bar comma C to be coplanar in that box ABC is equal to 0. If A bar comma B bar comma C bar are position vectors of points A comma B comma C with respect to 0, then the volume of the tetrahedron OABC is given by 1 by 6 into box ABC. Example. A bar is equals to 3i minus j minus 2k. B bar is equals to 2i plus j minus k. C bar is equals to I plus 3j minus 2k. Then find A dot B cross C. So we have to find A dot B cross C is equals to box ABC here by Probo formula. So it is equals to box ABC. So therefore, box ABC is equals to, or we can find out directly. So we can find out directly box ABC here. So we can uh, calculate B cross C is equals to ijk 2, 1, minus 1, 1, 3, minus 2. So simplify this determinant. So we are getting I plus 3j plus 5k. So A dot B cross C is bond paper, book stall, Anna. 3i minus j minus 3k dot I plus 3j plus 5k. So we are getting minus 10. So find the value of the parallelepiped whose edges are represented by A, B, C. So volume of the parallelepiped is given by box ABC. So box ABC is equals to A1, A2, A3, B1, B2, B3, last row C1, C2, C3. So that is the volume 2 minus 3, 4, 1 minus 1, 2 minus 1, 3 minus 1, 2. So simplify this statement. So it will use minus 7. The negative sign indicates the given vectors are left-hand system. Example: find a constant C such that given vectors are coplanar. So given vectors are coplanar is nothing but box ABC is always zero. So box ABC is zero. If the three vectors A comma B comma C are coplanar, then their scalar triple product is zero. A bar is equals to 2A minus J plus K. B bar is equals to 5 plus 2J minus 3K, comma C bar is equals to 3A plus 3J plus 5K. So box ABC. Determinant of 2 minus 1, 1, 1, 2 minus 3, 3, C, 5. So that is equals to 0. So expanding determinant, we are getting 7C plus 28. 7C plus 28 is equal to 0. So C is equals to 4 minus 4. If the given three vectors are coplanar, then T must be is equals to minus 4. T is equals to minus 4. Next, find the value of the tetrahedron whose vertices A vertex 1, 1 minus 1, B vertex 3 minus 2, 2, C vertex 4, 3, 2. Find D is equals to 5, comma 5, comma 3. First, you have to find out position vectors of A, B, C. So that is DA, BD, DC. So DA is equals to OD minus OA. So DB is equals to OB, OD minus OB. DC is equals to OD minus OC. So that this is OA vector, this is OB vector, this is OC vector, OD vector. So volume of the tetrahedron. So 1 by 6 DA, comma, DB, comma, DC. So DA, comma, DB, comma, DC. So therefore 1 by 6, 4, 4, 4, 2, 7, 1, 1, 2, minus 1. Determinant of matrix. So 4 by 6. So final answer is minus 6. So this is the volume of the tetrahedron. So vector triple product. So let A comma B comma C are given three vectors. And the triple product of A comma B comma C is denoted by A cross B cross C and defined as the cross product of A cross B with C. So note that A cross C is a vector quantity and represented by the vector perpendicular to the plane of A cross B and C. But since A cross B is perpendicular to A and B, comma, A cross C is lies on the plane of A and B. Properties of triple product. So that A, B, C are three vectors. A cross B. The result and A cross B cross C. So simply we can say that A cross B cross C is always equals to uh, A cross B cross C is equals to A dot C into B minus A dot C B dot C into A. So this is the final result. A cross B cross C is equals to A dot C into B bar minus B dot C into A bar. Second condition, second one, A cross of B cross C cross C is equals to minus B cross C cross A. So reverse is nothing but it indicates opposite direction. So example, A bar is equals to I minus 2J minus 3K. B bar is equals to 3I minus 2J plus 4K. C bar is equals to 4I minus plus J minus 2K. So then find A cross B cross C. We will see on next class.